Okay, so the normal distribution is continuous, it's bell-shaped, and it's symmetric. Remember that symmetric, primarily your mean, your median, and your mode are the same. We tend to label the normal distribution with the mean because the mean is the most important of the three. It uses all of the data values. The shape of that normal distribution is determined by two parameters, which are your population mean, and let me write the symbol there, that's mu, and the population standard deviation, which is sigma. And you can choose any value you can think of for the mean, any value you can think of for the standard deviation, except 0. And you can use those in any combination. So we have an infinite number of normal distributions. So whenever you're looking at these problems that we're going to see in this course, you have to be told the mean and the standard deviation. Otherwise, you cannot work the problem. The other piece that's important that we kind of touched on last Wednesday or last week was that the total area under the curve is 1 or 100%. If you'll remember, in the realm of probability, the probability of 1 means something's going to happen. When you flip a coin, something's going to happen. The probability that you're going to get a head or a tail is 100%. The probability if you roll a die that you roll a number less than 7 is 100%, because all of the numbers on the die are less than 7. So something's going to happen when you perform that event. Okay, so that's why the total area. And again, it looks a little odd because this curve here never really actually touches this horizontal number line. Okay, and you can prove that it's 1 using calculus, okay, which most of you probably do not care about. So you're going to have to kind of trust Miss Ralston. There are two different types of problems that you can encounter with the normal distribution. And to know the difference, guys, you have to really pay attention to the phrasing of the question. The first type, okay, if you want to call it type 1, it's not really called type 1, but if you want to think about it that way, type 1, the instructions are going to say something like, find the probability that, and then it's going to give you a condition. Now, there are some synonyms that are used instead of the word probability. They can interchange those words. Instead of probability, you might see the word percentage. You could also see the word proportion. And if they want to get real technical, it could say find the area under the curve. Okay, so those words are synonymous. They all mean the same thing. And you're going to have to know the difference between the phrasing, because that's going to help you know what command, if you will, to use in Minitab. The other type question, I'll call it type 2. It's really not called type 2. It doesn't really have a special name. It's going to say something like, find the X value given the probability. Okay, so the phrasing is different. And again, they may not always use the word X value. They might say something like find the cutoff score. It might just say find the value or find the score. Okay, it doesn't always have to refer to it as X. But the difference is, in one case, the first case, if you will, you're looking for the probability. In the second case, you're given the probability. So you have to pay attention to what information you are being given are told in the problem. We're going to look first at some examples related to this first type where you're asked to find the probability of a particular thing. Okay? So here's our example that we're going to look at this morning. And we're going to use this throughout this discussion. Okay? It's going to look like a paragraph, which to some students seems kind of scary because it's a word problem. Okay? But here's what it says. It says, according to the American College Test, ACT, results from the 2004 ACT testing found that the students had a mean reading score of 21.3 with a standard deviation of 6, and assume that the scores are normally distributed. Guys, there are 3 things that you have to know in order to work the problem. Okay? First off, we have to know that our distribution is normally distributed. Okay, so somewhere in the story, phrased some way, it's going to tell you that it's normally distributed. You have to know it's normally distributed, which is the big clue that you're going to use the normal distribution. Second, you have to know the mean of the distribution. Now, it doesn't specifically say here, but this is actually the population mean. And we will assume in all the problems that we deal with that it is the population mean unless we're told otherwise. Thirdly, you have to know the standard deviation. So if you're reading the question like on the computer, I would, as I'm reading through it, make notes of these things. I would say, okay, it tells me that it's normal. So I know it's normally distributed. So I'm good there. It tells me that my mean is 21.3 and that my standard deviation is 6. I just write it down kind of as a list. There is a fancy notation that you might see the computer use or see your textbook use. It's written this way. It says, my variable x approximates a normal distribution. We use the letter N for normal, with a mean of 21.3 and a standard deviation of 6. That's kind of the fancy-dancy shorthand. Now, I'm not getting caught up in that shorthand, but it says my variable, which in this case is your ACT scores, approximately normal, N is for normal, with a mean 21.3 and a standard deviation of 6. Okay, so that's my big scenario. Then in the next sentence, okay, it's going to ask me a question. Okay, so here's the question. Find the probability let me get my paper out of the way. That a randomly selected student has a reading ACT score less than 20. Okay, so we want to know what's the chance that a student is going to score less than 20 on the reading ACT. Now, we already know that we have a normal distribution. We know the mean and we know the standard deviation. I like to draw a picture of what's going on, okay? So I'm going to try to do that. When you draw the picture, you draw the horizontal number line, the bell-shaped curve. We label the mean, which is given to us as 21.3. Now I know the standard deviation is 6. I don't really label it anywhere on the graph. Then it says find the probability, so I know I'm looking for a probability, that it's less than 20. So I want to finish drawing this picture. Guys, the mean is 21.3, and we treat this as a number line. So I hope it makes sense that 20 is going to be to the left of 21.3, because if I were looking at that as a number line, 20 is smaller than 21.3 and would be to the left. Everybody good with that? And then we want to know what's the chance that I'm going to be less than that. So I'm actually looking for this red shaded region, which if this were a perfect rectangle, we could think about using the area. But this is not a nice little rectangle. This is a curved region. We could do calculus. Probably most of you don't want to do calculus. So we're going to let the technology, Minitab, do this for us. Guys, you cannot, unless you know calculus, you cannot do this by hand. Okay, you've got to use Minitab or some other form of technology. We're going to use Minitab. Okay, everybody ready? I'm going to Minitab. Okay, we go to the top menu bar to graph. Okay, and I'll make you some notes as we go over here so we can keep up with what we're doing. We're going to graph, and we're going to choose probability distribution plot. Okay, because we're talking about probability distributions, and I want Minitab to draw me the picture. So we go graph, probability distribution plot. And when you click it, our little wizard comes up. And there's different things that Minitab will do. We are looking for the probability. So you always choose view probability and click OK. So we choose view probability. And then my little wizard comes up. I have to tell it what kind of distribution. Guys, the only type distribution that we've talked about to date is the normal distribution. That is the default. I then have to enter the mean that is given in the problem in the box. So my mean was given as 21.3 and my standard deviation as 6. Then you need to go to the other tab. The other tab is labeled shaded area. And here's where you got to make a decision. It says, define shaded area by probability or by an X value. The question said, find the probability. So we're using probability. But then I have to decide, should it be right tail, left tail, both tails, or the middle? Okay. The question said less than. And if we go back, let me see if I can toggle back. If you go back and look at the picture that we drew, where is that red shaded area? Isn't it on the left? Less than is going to be on the left. So we need the left tail. Okay. So we choose left tail. Oh, I'm sorry, I told you wrong. We need to tell it X value because we're looking for the probability. Okay, I told you wrong. I'm sorry. You have to define the shaded area by the X value because you're looking for the probability. We don't know the probability, but it's still left tail. And our point of interest was, is it less than 20? So 20 is my point of interest. So I tell it, okay. And it draws this picture, okay? This number right here. See this number kind of off to the side where that red region is? It's a decimal, 0.4142. Ta-da! There's the answer. Okay, so our answer here, let me finish writing the instructions. So we view the probability, we choose the normal distribution, we enter the mean and the standard deviation. Then we're going to do it by the X value. This one was left tail. And guys, every time you see a less than, it's going to be a left tail. That ought to make sense. Less is to the left. Okay, and then we entered the value of 20. Okay, so this red shaded region here, the probability is 0.4142. And you're typically asked to write it with 4 decimals. It gives you 4 decimals in Minitab because before, way back when in the olden days, before we had computers or calculators to do this, and scientists were having to do calculus, one way that they got around it sometimes was to use a table. And the table that was created always had 4 decimal places. So that's kind of a carryover from way back when, but we still do 4 places. So that tells me that there's about a 41% chance that a student is going to score less than 20 on the ACT reading in 2004, because that was what we were focused on. Okay, you ready for the next one? Okay. Same scenario. Okay, so we still have ACT scores, normally distributed, standard deviation of 6, and a mean of 21.3. Okay, that hadn't changed. So now we're going to find the probability. Find the probability a randomly selected student scores greater than 30 on the reading ACT. Okay, the question itself is almost worded the same way, okay? It's still asking me to find the probability, but this time it says greater than 30. So visually, again, I have my horizontal number line, bell-shaped curve, mean is in the middle, which is given to me as 21.3. Remember, the horizontal axis is your number line. 30, the number 30, or the score of 30, would be on the right-hand side, because 30 is bigger than 21.3. I hope you guys can follow a number line. Okay, and we want to be greater than that. So now we're looking for this red shaded region to the right. Okay, so we do have to think about, again, for Minitab, we need to think about, Is it right tail, left tail, middle, or outside, I think is the term they use. Okay, notice that this red shaded region is on the right. And guys, anytime you see greater than, it's going to be to the right. So this would be what we call right tail. Anytime you see greater than, it's right tail. So I'm going back to menu tab, back through the same steps. Graph, probability distribution plot, view probability. I'm still a normal distribution with a mean of 21.3 and a standard deviation of 6. That hasn't changed. My shaded area by an X value, but this time it's a right tail, and my value is 30. And I click OK. And a different graph appears, okay, on the screen, and we're looking at that decimal value that's written above the curve. It's this value right here. Okay, so we have let me write it down, 0.07353. Now in this case, they give you 5 decimal places. Okay, if you need to round to 4, the 3 is next door, so it's not going to bump the 5. So this will be approximately 0.0735. So there's roughly, in terms of the explanation, and I'm going to write this one out since I have a little bit of room, I can convert that to a percentage by multiplying by 100. So this means there is approximately a 7% chance that a student scores greater than 30 on the reading ACT. And that's really the interpretation. Now, really, all they usually ask you is for this decimal value right here. You don't have to write out that sentence. But if you were writing a report to share with other people, then you would probably need to write such an explanation. Now, one other thing that I'll point out to you here, because you'll see something a little bit different in the next module, is notice that we're selecting a randomly selected student. We're only picking one. In module 3, they introduced the idea of selecting maybe 4 students or 10 students or 20 students, looking at a group of students as opposed to a single individual. Okay, so they introduced that concept at the beginning of module 3. All right, let's do another one. There's 4 different scenarios, if you noticed. So I want to try to do an example of each scenario. And honestly, I really think, guys, if you'll draw yourself a picture, it really helps you. It's the same scenario again, ACT reading scores, mean of 21.3, standard deviation of 6. This time we're going to do find the probability that a randomly selected student scores between 18 and 24 on the reading ACT. Okay, so again, the phrasing hasn't changed a whole lot. It says find the probability, but it tells us to do between two numbers, 18 and 24. So again, I'm going to sketch me a picture. I have my horizontal number line, my bell-shaped curve. The mean is in the middle, which we're told is 21.3. This time we want to be between 18 and 24. So 18 would be on the left-hand side, 24 would be on the right-hand side, and I want to be between it. So we're looking for this red shaded region. Now again, if you think about the terms that are given in Minitab, this is the one for middle. Okay, because you're between, or you're in the middle of 18 and 24. Okay, so you're going to use the middle option. Back to Minitab, same commands. Graph, probability distribution plot, view probability. Okay, I have a normal distribution with a mean of 21.3, standard deviation of 6. My shaded area by the X values, because we know what they are. We know 18 and 24, and I want to be in the middle. And it now has two blanks here, okay? It says X value 1 and X value 2, so you got to tell it what the two extremes are. Guys, you always work left to right, okay? So you're going to put the smallest one first, so that's 18, and then 24 is the highest. Always work low to high. And then I click OK. And again, I get this picture of the curve, okay? At the very top, it has 0.3825. 0.3825. So the area of this red shaded region, which corresponds to the probability, is 0.3825. Because Minitab's doing all the work as long as you tell it what to calculate correctly. And it will help you, in my opinion, if you'll draw the picture first. And again, on the homeworks, they're going to ask you for this 0.3825. Again, our explanation here would be there is approximately a 38% chance that a student scores between 18 and 24 on the reading ACT. Everybody okay? Going too fast for you? All right, that's the third type. We got one more. Okay, so same scenario again, ACT reading, mean score 21.3, da-da-da-da-da-da-da. Okay, so this time we want to know, find the probability that a randomly selected student scores less than 17 or greater than 25 on the reading ACT. Again, notice it says find the probability, but this has two pieces to it because it says less than 17 or greater than 25. So I have kind of two conditions. Remember, with or, it could just be less than. It could be just greater than. The option is it could be both, but in this scenario, it can't really be both at the same time. Okay, so let's draw a picture. Horizontal axis, bell-shaped curve, mean in the middle, just 21.3. We have less than 17, so 17 is on the left, and we want to be less than. 25 is on the right, and we want to be greater than. I can't remember off the top of my head what Minitab calls this one, so we'll write it down in just a minute. Okay, so go back to Minitab. Same commands. Graph, probability distribution plot, view probability. It's a normal distribution, mean of 21.3, standard deviation of 6, my shaded area. This time I want it on the ends. Minitab calls it both tails because it's on both ends. So it calls it both tails. So typically when you have that or statement, you're going to use both tails. Okay, so I want both tails. Let's see. Oh, both tails is not going to do it. All right, we'll have to make a little adjustment here. Okay, we're still going to use middle, but we got to do we'll have to do something special. Okay, still have to use the middle, but we'll have to do something special. So this will be a special case. So we're doing, this time we're doing 17, less than 17, and greater than 25. Okay, this is going to probably bother you because this picture doesn't look like the one that I drew. This picture gives you the value of the distribution between those two numbers. But what I really want is what's on the extremes. In this case, I'm really looking for the white area. Okay? So I know, let me write it in here, 0.4945. Minitab tells me that this region here from 17 to 25 is 0.4945. That's this area in the middle. I'm looking for these regions on the end. Well, we said a little while ago that the area under the entire curve is 1. So if I take one whole and I subtract off the piece that's in the middle, that should give me what's left. Okay, so this has an extra step. The OR has an extra step. So we have to do 1 minus 0.4945, which is 0.5055. This is the answer that you would want to give if this were a question on the test or a question on your homework, or a question on a practice problem. So it's sort of like this, okay? It's like you've got a whole pizza and you've eaten the middle out. So you want to know what's left. So I took the whole pizza, I subtracted the middle that I ate, 0.4945, and this is what's left. So there's about a 50% chance that a student would score less than 17 or greater than 25 on the reading ACT. That's an extra step. You follow me? It's probably not likely that you're going to use both tails. Both tails would be if you wanted the area, wanted it to be the same on either end, and we don't typically do that. So, okay, so you have an example of the 4 different types where you're going to use the X value. In each of those cases, you were given a cutoff score. You were given a value like 17 or 30 or 23 or 25. Okay, now I want to shift gears. Okay, now I want to shift gears and look at the other type question or type 2 question that you can see when you're looking at these problems. And we're going to use this same scenario because you can have either type question with the same scenario. So we still have the ACT testing, mean reading score was 21.3, mean of 6, or excuse me, standard deviation of 6, and it is normally distributed. But this time, it could be something as simple as find the 82nd percentile. Now, again, there's lots of ways they could word it. Okay, it says find the 82nd percentile. They're actually saying find the X value that corresponds to the 82nd percentile. Okay, they just shortcut it and just say find the 82nd percentile. But they're really asking you to find the X value that corresponds to the 82nd percentile. This 82nd percentile corresponds to your probability. Okay. So you got to kind of know how to interpret, and we talked before how to interpret the 82nd percentile. So I'm going to draw me a sketch here. Horizontal axis, bell-shaped curve, mean in the middle, just 21.3. Now, a couple of things to remember that you may have forgotten. Okay, a couple of things to remember. Remember, the mean is your measure of center. So that means you have 50% of your values below the mean, and you have 50% above the mean. Okay, because you got to kind of think about where 82% is. Furthermore, you have to remember that when you interpret a percentile, remember the percentile is the percentage below the given score. Okay, so I got to think about where is 82%. So if I start at the left, we always work left to right, so we start at the left, so that would be like 0%. I get to the mean, I'm at 50%, so I got to go a little bit further. So somewhere over here on the right-hand side, that tells me that I'm going to have 82% below my score. And I'm using 82 because I'm looking for the 82nd percentile. I'm looking for this value right here. This is going to be an X value because I already know the probability. Okay, so it's a little bit different wording, but you got to pay attention and know, should you be above it or below it? You know, this because the interpretation of a percentile, we're below. And again, notice when we're below, we're on the left. Because we got to tell it whether it's going to be left, right, both, or in the middle. Well, I'm on the left because I'm less. Okay, so here we go. It's a little bit different thought process. Got to pay attention to the wording. Okay, so this time we still go, we use the same command, graph, graph, probability distribution. We still want to view the probability. It's still a normal distribution with a mean of 21.3 and standard deviation of 6. Shaded area. Now I want to define it by the probability because I've been told the probability is 82%. And I'm doing a left tail because we interpret the percentile as less than, and you enter your percent as a decimal, so 0.82. Okay. So when you look at this distribution plot, it shows you that this red shaded region is 0.82. So that's my 82%. So I come down here to my number line and I see the X value. My X value is 26.79. 26.79. So if a student scored approximately 27 on the reading ACT, they would be considered in the 82nd percentile. You can think about it, there's an 82% chance that someone's going to score below 26.79 or below 27. Okay, let's do another one. I typed this one out because it was kind of lengthy. It says, the local high school awards a scholarship to each student in the top 3% of the ACT reading scores. What score would a student need to qualify for a scholarship? And I left off my question mark. Okay, so it's not just as straightforward. Okay, it doesn't just say find the whatever percentile. Okay, but what I notice when I read this question that's different from the others is it says top 3%. I'm given the percentage. I start out knowing the probability or knowing the percent. It also uses the word what score, so it tells me score at what X value, okay, should I have. So let's draw a picture. Horizontal axis, bell-shaped curve, mean in the middle, just 21.3, excuse me. Now this time it says the top 3%. So should we have a shaded region on the left, in the middle, or on the right? Why? Who said that? Why on the right?
Because it's the top.
Because it says the top. Very good. Very good. Guys, use your noggin. Use a little bit of common sense. Top 3%, that's going to be high. Okay, so we know it starts at 0 and works its way to 100. So somewhere over here, I'm going to have a cut score for the top 3%. Now you do have to write that as a decimal. Remember, 3% would be 0.03. Now, I tried to stress that to you because one thing that means is that when you go to do your command in Minitab, this time it's a right tail because I want that upper end. Okay, I want the upper end. Back to Minitab. Graph. probability distribution plot, view probability, still normal, still a mean of 21.3, standard deviation of 6, shaded area by the probability because I have the percentage. It's right tail because now I want the top half, and it's 0.03, and I tell it okay. And it shows 32.58. 32.58. So in order to qualify for a scholarship, a student would have to make approximately 33 on the ACT reading. Okay, so you just write the number down. I would tell you to be cautious about how they ask you to round. Do they ask you to round to a whole number, to 1 decimal place, 2 decimal places? And guys, it may change from problem to problem, so it's important that you pay attention. All right, let's look at another. We're going to completely change the problem. And you can decide. I'm going to let you decide here in a minute. Okay, it says, women's heights are normally distributed with a mean of 63.6 inches and a standard deviation of 2.5. The U.S. Army requires women's heights to be between 58 inches and 80 inches. Find the percentage of women meeting that height requirement. Are many women being denied the opportunity to join the Army because they are too short or too tall? Okay, so a couple things. Notice in the first sentence, it tells me that I have a normal distribution, so I know it's normal. It tells me that my mean is 63.6 inches, and it tells me that my standard deviation is 2.5. So I have the 3 things that I need. I know that it's normal. I know the mean, which is 63.6, and I know the standard deviation is 2.5. In the fancy writing, you would have that your variable approximates a normal with a mean of 63.6, standard deviation of 2.5. Continue reading, and it says, the U.S. Army requires women to be between 58 and 80 inches. Find the percentage of women. Okay, so this one uses the word percentage as opposed to probability, but I already told you that was a synonym. Okay, so let's see if we can sketch us a picture here. Horizontal axis, bell-shaped curve. The mean is in the middle, which is 63.6. And we want to be between 58 and 80. So you're looking for this red shaded region that's kind of in the middle of the graph. Now, when we go to Mini tab, we go through our command, graph, probability distribution, view the probability. It is normal. At this time, we need to change our mean. It's 63.6, and the standard deviation is 2.5. Should we do it by probability or X value? This is the X value, okay? So I'm gonna make a little note here that we're gonna use X value because we're looking for the percentage. And should we do right tail, left tail, both tails, or middle? This is middle because you're doing the between. Okay, so my lower value is 58. The upper value is 80. And you get this picture. And it gives you that probability, okay? 0.9875. So the probability that a woman is eligible to join the Army is 0.9875. Okay, so there's, roughly a 99% chance that a woman meets the height requirements and can join the Army. So the second question there says, or kind of the lingering question says, are many women being denied the opportunity to join the Army because they're too short or too tall? What percentage cannot join the Army? 1.25. Okay, remember the whole curve is 100%. So 100% minus 98.75 is 1.25. So 1.25% of the women within the United States are not eligible to join the Army. You think that's too many? You think too many are being denied? I don't really think so. I mean, that's pretty low probability. And you got to think be 0.0125. That's, I would think, in the overall scheme of things, that's reasonably close to 0. And 0 means it's not possible or impossible. So, my gut says we're okay. The standards that they have set, they're okay. They're catching most women. Okay, let's see if we can go through one more before we go. I got 8 minutes. This time it says, men's heights are normally distributed, so they're telling us that it's normal, with a mean of 69 inches, so they're giving us the mean, and a standard deviation of 2.8 inches. Okay, so we have all of the information we need. Our variable, which is men's heights, is approximately normal with a mean of 69 inches and a standard deviation of 2.8. So I have all of the information that I need. It then goes on to say that the standard casket has an inside length of 78 inches. What percentage of men are too tall to fit in a standard casket? Okay, so I'm going to label this one as number 1. Okay, so it says what percentage, another word for probability, are too tall. Now you may have to think about what being too tall means in this context. What would it mean to be too tall in this context? Taller than the casket, and the casket is 78 inches. So we're really saying that the men are greater than 78 inches. So sometimes you have to think about what that means, okay, because they don't make it abundantly clear. So let's see if we can draw ourselves a picture. So we have our horizontal axis, bell-shaped curve, mean in the middle, which is 69 inches. The casket is 78 inches, and we want to know if they're too tall or greater than 78 inches. So again, just to kind of make sure you get it, you're going to do an X value here because you are looking for the percentage and you have the X. And we're going to do right tail because we're saying greater than. So I'm going back to mini tab. Graph, probability distribution, view probability. It's normal, but my mean is 69 and my standard deviation is 2.8. Shaded area, we're doing right tail. They have to be longer or taller than the casket, which is 78 inches. Wow, we get 0.0006538. Okay, so this little shaded region is 0.0006538. If you round that to 4 places, we would have 0.0007. As a percent, you would have 0.07%. So we're saying roughly 7 out of 100 men would not fit into the standard casket. I mean, guys, that's less than 1%. Think about it, 0.0007 is really close to 0, meaning the casket's gonna fit virtually every man, 99.3, 03%, 99.93% of men. I think we're covered. Okay, but then question 2 says, let me see if I can get through it, I got 5 minutes. Question 2, or the second question here says, a manufacturer of caskets wants to reduce production costs by making the casket smaller. What inside length would fit all men except the tallest 1%? Okay, so notice in this question, they give you the percentage. And again, the phrasing may kind of throw you off, but it says what inside length. This is like they're asking you, what is the X value? Or what is the cutoff score? How much could he shorten the casket? Because if he can shorten the casket, then he doesn't have to use as much material, which in the long run is going to save him money. Let's draw a picture. Horizontal axis, bell-shaped curve, mean in the middle, which is 69 inches for men. And again, it says tallest 1%. We're going to be on the left, the middle, or the right? If they're tall, it's going to be on the right. Okay? Because if they're tall or tallest, they're going to be taller than the average. So it should be over here on the right. Okay, so we're going to cut off or exclude the tallest 1%. Now 1% is 0.01, be careful. So this question, the way it's worded, you're going to use probability, because that's what you're given. And you want, again, to do right tail, because you're cutting off that upper part, or the tall men. Okay, so here we go. Graph, probability distribution, view probability, okay. Normal, 69 with a standard deviation of 2.8. We're doing it by probability, right tail, and we're excluding 1%. Okay. And we get 75.51. Okay, so 75.51. Now, what that tells me, go back, okay? So the manufacturer could shorten the casket to about 75.5 inches and still fit all but 1% of men. You realize 75.5, you're looking at 6 feet 3 inches, 6'3". So think about it. You know, how many men have you ever encountered that are taller than 6'3", or about 6'3.5"? Okay, probably not very many. So he could shorten it, and if he shortened it, I mean, that's not 2.5 inches, guys. So think about it. Over the long haul, I mean, 2.5 inches don't seem like a lot, but if you're creating thousands of caskets, after a while, that's going to add up. And because you're not using as much material, then your profit becomes higher because you're not having to pay for extra material. Okay, questions?
Wouldn't you be able to do the same thing if you did the left tail instead and just did 99%?
Yes.
That's what I was talking
Yeah,
about.
you can do, if you want to view it always to the left, you can do that. And so in this case, you would do left tail with 99%. You can do that. And one of the reasons you probably were taught that if you were using a calculator, because the way the TI, Texas Instruments calculator is programmed, is it's programmed to always do area to the left. And that's partly because, again, if you go way back to the olden days when we had to use tables, that's the way tables were set up. So some of the newer technologies really makes it, in my opinion, a little bit easier because I learned it that way too. Other questions?